few announcements. So yeah, first of all, welcome everybody. Glad to see everybody here, especially some familiar names out there. So today we're going to do some talking about budworm, just a few housekeeping items before we get started. I just want folks to know that this will be recorded. So hopefully everybody's all right with that. And that recording will be made available after this webinar on our Maine Forest Service YouTube page. I also want folks to be aware that this is eligible for 1 forestry and 1 pesticide credit. So there will be a link to a chat or a link to a quiz that goes into the chat box. So that quiz will be required with a passing grade to get 1 or both of those credits, depending on what you're looking for. So I think that's it. All right, we got up to 27. So yeah, let's get started. Okay, and then if somebody will just give me a thumbs up that my screen is shared and everybody can see my cover slide, Spruce Budworm in Maine.
Yep, you're good.
All right, thank you. So, all right, here we go. Buckle in, everybody. We're going to spend some serious time talking about Spruce Budworm this morning. So for those that don't know me, my name is Mike Parisio. I'm a forest entomologist here at the Maine Forest Service. And I started with the Maine Forest Service in 2019, and that's when I took over oversight of the Spruce Budworm monitoring program with the Maine Forest Service. So it's been a pretty interesting series of years since I started that. So I wanted to take this opportunity to share some of those things in this five-year period. So we'll get right to it. So I'll start with some very basic Spruce Budworm basics. So despite the name, I think it's important that everybody know that balsam fir really is the most preferred host of this insect, and so that's where we see most of the activity with Spruce Budworm. But again, depending on population and stuff, it certainly does take advantage of spruce hosts. And then in a world of invasives, where that's pretty much what we talk about all the time, I do want to draw attention to the fact that this is actually a native defoliator. So Spruce Budworm is native to North America, and as a native insect, it's developed kind of a normal outbreak cycle depending on its environment. So typically in Eastern North America, that outbreak cycle is about every 30 to 60 years. Here in Maine, it's more on average of about a 40-year cycle. So yeah, the last great outbreak was back in the 70s. So we're right on time for potentially some activity, and that's what we're doing. We're monitoring for that activity right now. So bringing it back for some context about why we're talking about Spruce Budworm today and why we're concerned about it. So that goes back to remembering the big one. And I'm not one of them, but perhaps certainly there are some folks on this call that lived through this and experienced this right here in Maine. So that last major Spruce Budworm outbreak spanned roughly from the late 1960s to the early 1990s, with a definite peak period there in the mid 70s and the 80s, but end to end, a really long outbreak. And I want to point out that when Spruce Budworm outbreaks, it's typically a regional outbreak, so across the range of its hosts. So you can see here on this map. This is what that last major outbreak looks like. So it wasn't just Maine affected, obviously. There was over 136 million acres affected across Canada and Maine. So you can see all the way from Newfoundland to the Great Lakes, basically. So depending on the area, mortality was extremely severe. So some places 84 to 97% mortality. And again, because of this extreme outbreak, there was definitely plenty of feeding on spruce as well, in addition to that preferred balsam fir host. So you had anywhere of 30 to 66% mortality on red spruce as well. And I don't have stats for the other species, but anyways, that was a big deal. So it resulted in an estimated 20 to 25 million cords of spruce fir mortality. And that kind of translated to hundreds of millions of lost revenue to the forest industry. So again, some people out there have probably lived through this and saw this. So, just a couple of examples of the sheer landscape level devastation here. You can see all that discoloration from defoliation on the bottom right there. And yeah, we'll talk about some management strategies today. But again, that was the era of warfare against Spruce Budworm. So, World War II era planes, commissioned to spray many chemicals over the landscape to try and, basically save spruce and fir to the point where they could just keep up with it to be salvaged, which had limited success. So we'll just take a look at this graphic here on the left, and this just kind of shows some of the history here in Maine. So again, we're going to talk about the last great outbreak and what we're dealing with right now. But just to point out that that graphic starts all the way back at the turn of the last century. So Spruce Budworm, again, is a native defoliator. So there are endemic populations in Maine that have caused periodic problems from time to time, again, typically on that outbreak cycle. But yeah, you can just watch that scroll through that map on the left as we get to the great outbreak of the 70s and 80s. And it's kind of broken down there on the right. So you can see a year-by-year snapshot of all the areas that were severely or moderately affected by Spruce Budworm in Maine from 1972 there to 1989. So you can see some really major eruptions there. My graphic has stopped playing in 1965, so all right, we'll skip forward. Okay, so in addition to that context, I want to give some modern context on why we're dealing with Spruce Budworm in Maine or worried about dealing with it. And again, going back to the fact that this is a regional species that affects big regions at a time, we really have to talk about Quebec. So Quebec has borne the brunt of a modern Spruce Budworm outbreak, and this is what we're concerned about, is the influence of this break on our forests in Maine. So you can see they're really, ramping up in 2010 up until the present, or almost the present. So between, that 10-year period from 2010 to 2020, over 34.5 million acres of spruce fir forests have been affected in Quebec. So, and again, that's when we really started to look at what was going on here in Maine. We started to get some activity that was beyond what we consider normal right around 2013. So we've been monitoring pretty closely since then and before then. But yeah, again, I'm just going to focus on really the past 5 years or so of what we're seeing. So here's what the damage area really looks like for Quebec, and I'll share a series of slides here with year-to-year maps starting with 2018 to 2019. So again, this is what's going on in Quebec right around the time period that we're going to talk about here in Maine. So you can see quite extensive, not only in the distribution of Spruce Budworm in Quebec, also reaching out to Ontario there with a separate population, but that whole St. Lawrence Seaway area severely affected. So fast forwarding to 2019 to 2020, again, most of the same areas. And again, a lot of that moderate and severe damage, those yellows and reds going on just to the north of us. Things started to change a little bit in 2021. So you can see the change from that really severe damage there on the left in 2020 to 2021, but still definitely plenty of population up there. And then here's what things look like most recently. So it's kind of interesting that some of this population that we're most concerned about appears to have, receded a little bit. Again, we'll talk about why we're concerned about what's going on in Quebec and Maine on the next slide. But yeah, things are starting to evolve there. But you can see, on the contrary, the areas towards Ontario there on the left side of that 2022 map, those are starting to become more severe. Contrary to some of these areas in eastern Quebec becoming a little less severe. So I bring up all that Quebec context to kind of show, again, that Spruce Budworm is a regional problem, and depending on what's going on in one place, it really influences the whole region. So monitoring has become pretty sophisticated for Spruce Budworm in the form that we can do all this flight modeling and simulating based on atmospheric conditions. And it's really important to know that those atmospheric conditions really determine the distribution of Spruce Budworm on the landscape. So I picked a really nice, clear example, on the left side of this map here. So again, these are Spruce Budworm that are lifting off in Quebec, and depending on those prevailing winds and atmospheric conditions, you can see there's a plume of them that's headed straight for Newfoundland. And so it's no mystery that Newfoundland is also dealing with Spruce Budworm problems at the moment. So, and yeah, these models have been really useful for getting a heads up about what we can be expecting. So So this is a really obvious one, and then I'll go to this one from 2019. So same story happened to us in 2019 that happened in Newfoundland. So that Quebec infestation, again, caused these plumes of spruce budworm to lift off. And the most important symbol on these two maps are these little yellow suns. And so you can see in the legend there that the yellow suns mean that these spruce budworm were successful in making it alive to that destination. So a lot of the spruce budworm during these mass dispersal flights are being carried around by atmospheric conditions. They die. So you can see, for example, the St. Lawrence Seaway in that map on the right, all of those spruce budworm that never make it across the water and they die. And there's a whole variety of reasons that these spruce budworm, die in transit, never make it. But yeah, again, 2019 was really significant for Maine because we had these two big nights, especially the night of the 20th, where we had all of these spruce budworm, touch down in good condition in northern Maine. And so that's what we've really been, monitoring carefully for. And so that's what the Spruce Budworm Pheromone Trap Network is for. So again, we had this in place. This isn't in response to that big flight. But yeah, this program goes back to the 1990s. So again, that's kind of the tail end of the last great outbreak, the very tail end. But we wanted to, be sure we were prepared for the future. So we started with a small subset of traps. It was less than 100, I believe. And so those got established with a core set of cooperators, Maine Forest Service, U.S. Forest Service, Irving, J.D. Irving, and the Penobscot Nation, to name them. And then, this is what it's grown into today. So there's been a lot of interest, especially from large private landholders in the North Maine woods, to know what's going on. And so we have this fabulous cooperator network. And now we're up to over 350 sites annually throughout Maine. You can see them, how they're dispersed there on the right. And it's even been as high as 450 in some years. So, but 350 is really the basic number that we work at right now. And again, our cooperator network has grown from just those 4 core cooperators when the program was launched in 1992 to over 20. And yeah, I know some of those cooperators are on the call this morning or the webinar. So thank you in advance for all your help with this. So this is how this program works. And I'll just add this in here because there wasn't any better place to stick it. But we've also borrowed a few automated pheromone traps from the Canadian Forest Service. And these are basically traps that provide daily information. So we have 2 of those that have been operating for 2 years, one in New Canada and New Stockholm. And I just want to mention that because that's another piece of the puzzle is as we evolve here, with shifting climates and stuff, it's really important to know when spruce budworm is active to see if those dates are changing and stuff, so we can do a better job of monitoring. So yeah, that's really useful information. And you can see on that map on the left there how our 2 main traps plug into a greater network that's been ongoing in Canada to kind of monitor activity across the region as far as when spruce budworm starts flying for the season and ends. But anyways, back to the main pheromone trap monitor network. So again, we have, on average 350 or a little better traps all across the state, even year. So here's prior to that big 2019 event where we had all these moths fly in. And so things are pretty, they're a little elevated. They're not horrible at this point. You can see, a couple of these larger categories. So that's what I'll kind of focus on going through these. So most of these points on these early maps, they're pretty small or average trap catches. And this largest category where you're having an average of 150 or greater moths, that's usually just a very few. So you can see in 2018, or you can't see, but in 2018, it was 2. So that's pretty typical for a given year. So 2019 is where things get interesting. You can see that top category. You can see all those stars. That jumps to 45 with a maximum of an average of 716. So, 2,000 moths at a single site where there's 3 traps. So yeah, this is an astronomical increase here. But again, because of these flight models, we know that most of what's showing up in these traps did not, originate in Maine forests. These are moths that blew in from the Canadian outbreak or the Quebec outbreak and wound up in our traps. So yeah, this is the interesting thing. We know that these moths arrive, so what's going to happen with this population now? So fast forwarding 1 year. So here's again, so 2019, the year of the big in-flight. Yeah, surprisingly, and quite a relief, things they did not remain at that level. Again, that's kind of an artificially high number in 2019, what we're seeing based on that flight of moths from Canada. So over here in 2020, we do still have a lot of high or elevated sites. You can see that biggest category again, averaging 150 or better. It's still up at 16, so that's out of the norm. We're above what we call endemic levels. So yeah, again, an interesting thing. So let's see what happens going forward. And again, 2021, we had a couple more of these, not as severe as the 2019, but it remains to be seen how these in-flights from the Canadian outbreak are going to affect us as well. So again, these yellow suns here, these are the moths that are arriving in northern Maine, and these are, in good enough shape to survive and get established in Maine forest. So here's a second influx again. And again, another night in 2021, right around the same time, same kind of prevailing, wind and atmospheric conditions that deposited some moths in northern Maine, hypothetically. So seeing that, we had some reason to be concerned, but again, 2021 proved to be interesting. So looking at 2020, where we still had that elevated number of those highest traps there, we drop all the way down to just one at that highest category, and that's up here in Madawaska. Kind of an interesting story. We would have expected things to stay high, but they appear to have tailed off somewhat. And then here's the most recent map from this past year. So yeah, things look quite different. And yeah, we've kind of changed some of our symbology to better capture what's going on. So yeah, you'll have to read between the lines a little bit, obviously with the different legends. But again, we're kind of, staying at those those same levels and kind of dropping off. So again, Madawaska, 2 years in a row there, that single site has the greatest average there. But we only had one in that bin of 150 or greater, the last 2 years. So that's a good sign. And things are they're still elevated, but they're returning to a more acceptable level. So yeah, here's what a graph looks like for the breakdowns of these average traps. So again, every one of these sites has 3 traps, and we average the moths based on how many traps are successfully sampled. And so you can see, obviously, most of the traps in this program are in Aroostook County. So Aroostook County is really the driver of the patterns and stuff. But pretty much all of these counties, again, show that 2019 peak in most of them. And again, the Aroostook County results are really going to drive the statewide results. So you can see right there. But again, we had a steady buildup, a population explosion based on that in-flight, and then we're kind of returning back down the backside of the wave, and we're in that, questionable period to see, if we're going back up, are we in a trough and we're going to go back up, or are we going to kind of stay there? So. And yeah, this just shows the percentage of sites statewide and their average cap. So again, most of the time, for these low categories, we're averaging less than 50 moths per trap. We're up around 90% is pretty typical, and then a small distribution. So, but you can see in 2019, where we typically get 90%, that low capture bin really drops out all the way down to, just over 60. And that's where they're going. They're going into these really high average capture bins. So you can see how these graphs kind of nest together nicely, where you can take these 2019, higher bins, and they would fill up that space in that lower category in a normal year. So again, just illustrating the point that, certainly the 2019 season had a great influence on what's happening right now. So yeah, I mentioned before when we started talking about the pheromone trap monitoring network, we do have a core set of of traps that have been operated since 1920 or 1992. So here in 2019 or 2022, we're at the 30-year anniversary. So you can see a little bit better, how this population fluctuation works. It's not uncommon to have these little bumps and stuff. Again, and when things started to blow up in Quebec, pretty much the same thing for here in Maine. We started to get some more activity. 2013 was where we became pretty concerned and started, paying a lot more attention and getting our ducks in a row during this period. A dip here, and then here's the 2019 population explosion from that in-flight, and we're back down here. And this graph is unfortunately a little misleading. We had a big number of sites that belong to this long-term network that we couldn't get samples from this year. So, and those sites happen to be very low every year. So that kind of allowed that average to drift back up to 15.2, but it's really not that similar from 2021. If we had all those low counts in there, this average would have been pulled down. But based on the data, that we got, this is where we're at in 2022. So again, elevated over kind of the historical norm during the duration of this long-term monitoring program. But yeah, we're not in horrible shape. So another way we monitor for spruce budworm, it's not intentionally for spruce budworm, but it's certainly does the trick. We also monitor light traps all over the state, and this is a really long-term running project, going back to the 1940s, I believe. So again, these light traps, some of them are in the North Maine woods, some of them are coastal Maine, but when spruce budworm populations are high, they do tend to show up. So yeah, this has been kind of an undulating story here, but yeah, 2018, we already had a peak before those big in-flights, and then 20, and again, here's where the Canadian moths show up from that migration event, so all the way to 507, and this seems pretty drastic, but I was looking through the old data, and back in the 70s and the 80s, it wasn't uncommon to have 10,000 spruce budworm in a light trap for certain traps. So that's when things were really bad. So again, above our modern normal, but yeah, not indicating a serious outbreak or anything like that. And then, yeah, whatever happens, not getting another influx, that number dropped off again, and we're back down here to kind of that fluctuating zone. We did go up a little bit from 2021 to 22, but still, we're kind of at that operating average level. So another thing we do is we look at defoliation. So spruce budworm is a messy feeder, so defoliation can be monitored when it's present. So I just want to talk about one of the methods we use. And this method goes way back. So it's called the FETIS method, and it basically, this is what we're using for our on the ground defoliation surveys and the defoliation surveys that happened at the University of Maine Spruce Budworm lab. So, very short and sweet. It just basically involves looking at branch samples from the mid or upper canopy and assessing each branch tip and giving them a score, and then taking the average across, the branch sample to kind of generate, an average between the three samples for the site. So, but yeah, after the 2019 in-flight of moths from Canada, we started monitoring 60 sites in northern Maine on the ground each year, and so here's what the results look like for the first 2 years of that. So again, if you take a look at the legend, we have some pretty elevated defoliation levels, this category of 20 to 30%, and then as much as 30 to 40%, especially here in New Canada, this one. But pretty much these results look identical. There's only a couple points that are different from year one to year two. So again, we do have some elevated stuff going on. We don't have a lot of change happening between 2021 or 2020 and 2021. So where that change comes in is, this should actually say 2022 up here. My apologies, but the math is correct. So when we look at 2022. We actually eliminated all those higher categories, and you can see all these are the same symbology here at a defoliation less than 10%. And that's because, as it applies. Defoliation levels that we were able to observe on the ground really receded. So again, the past few seasons, it's been easier to find spruce budworm larvae and defoliation, on the ground, just during everyday work in northern Maine. But for whatever reason, that those detectable levels have really receded in 2022. So things are looking pretty stable from that standpoint. So going on to the statewide defoliation survey. So again, this uses that same FETIS methods, and so I'll get into L2 or overwintering larvae monitoring later. But most of these sites are the same as the pheromone monitoring sites. So we ask folks to take 3 branch samples, and those go into the lab, and they're first assessed for defoliation before they're assessed for the presence of overwintering larvae. So here's what it looks like on the statewide map. And again, 2019, if we look at, not just our 60 sites in northern Maine, if we look across the whole landscape there, we certainly have some unexpected higher categories here. So you can see here on the left, plenty of stuff that's above 25%, and then we have this category that's 50 to 98%. So quite a good distribution. It's not clustered really. It's really all over this northern part of this network here, where we have some of those higher levels of defoliation. So same symbol is used on the map on the right here, but again, if you look at these categories, these percentages have really decreased a little bit. So we kind of see most of this defoliation damage kind of receding towards northern Maine, where the majority of those moths landed and stuff like that. So some of these bigger numbers in the rest of the southern part of the trap zone or whatever, they do appear to have come down a little. So another thing we do is we monitor for spruce budworm. During our aerial survey, we monitor for all sorts of things, but 2021 was pretty significant because we haven't been able to detect any spruce budworm damage during aerial surveys since the early 90s, 92 or 93. Again, at the very tail end of the great outbreak, there was the last time we were really able to document this. So we've been looking for years, and 2021 was the first time that this really showed up. And we had plenty of locations that we knew about in northern Maine where we had reports on the ground to fly over. So here's a couple of examples of those. So it's pretty subtle damage, but knowing where it is, we are still able to detect it. Maybe you can just see, this one's pretty universally discolored here, but here you have the contrast of spruce budworm working in there. So again, we had about 850 acres across northernmost Maine detected, and unfortunately, or actually fortunately, I guess, but kind of frustratingly, we were unable to pick up any evidence of damage again, even at these sites or anywhere else in 2022. So I guess that speaks to the fact that, as we kind of noticed on the ground, we did notice from the air as well that defoliation levels just seem to have come down a little bit. All right, so now I'm going to get into the overwintering larval survey and how we're looking to apply what's called the early intervention strategy in Maine. So the 3 things I want to get across here is one, that spruce budworm overwinters as a second instar larva, and that can be used to monitor, and it can be used as a pretty reliable population indicator. So based on work that's happened in Canada, we kind of know that by doing that monitoring, the threshold of 7 larvae per branch sample has been identified as the threshold for where you start to see significant defoliation damage, and therefore that's also the time that you might want to choose to apply management. So looking at the life cycle, this is what we're talking about here. Spruce budworm overwintering as a second instar larval. So this is where we're taking branch samples, and here's what that concept looks like on a graph here. So basically, this is what we consider the endemic population level of spruce budworm, and as other outbreak species go, they exist and they're here. But then at some point, there's some sort of trigger that releases, and this is the eruption threshold right here. So that's what's kind of being assumed to be that threshold of 7 larvae per branch. So once you reach that, you kind of open up the possibilities for population to really explode on this continual growing curve. So the concept of early intervention strategy is to identify that point and then to treat early. And what the attempt is to treat at this point where you can bring populations down below that eruption threshold with the minimum effort, and return them to this population level where things like natural predators and other natural controls are working to keep their populations in check. And so this is a drastically different concept than what was happening in the 70s and the 80s. Obviously the situation was out of control there, and the strategy used there was kind of called foliage protection. So again, massive aerial sprayings, blanket sprayings of pretty bad pesticides to just try and knock budworm populations back long enough where spruce and fir would still be viable for harvest. So again, the intent, or maybe it was the intent, but it was never successful at saving any of these trees. It was just kind of prolonging that period where you could still do viable pre-salvage and salvage. And so yeah, New Brunswick has really been the pioneering entity for this early intervention strategy, EIS, and we've learned a lot from them. And yeah, I'll just show you this map here on the right. So again, these are the situation in Quebec, and it's pretty startling that this damage really seems to hold up at the border. And yeah, just a few small pockets here in New Brunswick, but you can vaguely see there's hundreds or thousands of points, and this is the New Brunswick larval monitoring network. So all these points is where they take branch samples, and using that data, they can really accurately, spray early, again, spraying, low in the population curve and knock these things back. And they've showed some really great success doing this for a number of years now. So that's what we kind of decided to try and emulate here in Maine, where possible or where needed. So yeah, getting on to the L2 larval extraction process. So I'm not a lab worker myself. This is a pretty complex process, but yeah, we're really excited. We used to have this process performed by the Canadian Forest Service for us, but identifying the need to be able to do this right here in Maine and get quick results, spurred the creation of the Spruce Budworm Lab at the University of Maine. And so we're super excited to have this resource available, and it's been a monumental help so far. So I'll summarize this really quick. The branch samples come in. They basically get cut up into small things, soaked in a sodium hydroxide solution. They get rinsed through a sieve to kind of separate any of the organic matter. Then they're filtered. They go into these storage jars. They're put into this device here with hexane to kind of separate, again, that organic matter. The hexane's drawn off. You can see kind of the difference there between what's suspended and what's not, and then goes through this elaborate funnel through these filter papers with grids drawn on them. And so this is everything that's come out of one of these branch samples that goes under the microscope, that gets examined carefully. And based on the anal comb of a second instar spruce budworm larva, you can tell exactly what you got. So again, these pull in all sorts of other fun things, but yeah, it's pretty painstaking work to say the least, and it's a complex process, and yeah, it's fabulous to have this capability right here in Maine, and it's been eye-opening for what's happening here. So here's what all that work does for us. It creates this great map of what's happening on the landscape. So again, here we look at 2019. This was a preliminary results maps, but you can see all these red points. And again, remember talking about that threshold of 7 larvae per branch as being, our trigger point where maybe we do need to try and do some treatment here. So even though we had some elevated numbers here in 2019, nothing above 4, so there was nothing to do. And so fast forward 1 year, we wind up in 2020. And so this is the year that the first hotspot. So again, I'll refer to a hotspot as a point where more than 7 larvae per branch were detected. So that's up in the Cross Lake area. And so, yeah, by virtue of this survey and results performed, here in Maine, we identified this, instantly. And this was the first one to breach that threshold, coming in with an average of 7.66 larvae per branch. So, yeah, and basically when this happens, when we find a hot spot, it triggers additional sampling. So we can go out and we can take more samples from a higher density grid. And using that, we can basically connect the dots. So we can, instead of, again, remembering that the broadcast blanket spraying, indiscriminate spraying over everything that happened in the 70s and 80s, we can use these points, where we know we have slightly elevated or, no larvae or highly elevated larvae. And we can draw the smallest possible spray blocks. And so, we can treat the absolute limited number of acres. We can do it more effectively with, rotor wing versus fixed wing, aircrafts that are blanket spraying. And we can do it with some better chemicals too. So this particular hotspot resulted in 2 little spray blocks there. And it was treated by a private landowner there with 4A. And again, the active ingredient in 4A is Bacillus thuringiensis variation Kerstaki, so BTK, which a lot of the pesticide applicators on here are probably familiar with. So again, BTK is a much more benign chemical than the things that were being used to target spruce budworm that certainly had all sorts of non-target effects. Again, BTK is not perfect. It does target Lepidoptera. It does have some non-target effects, but when you're figuring out the cost benefit, it is a practical chemical to use for situations like this where we can net back spruce budworm populations with having minimal effects on other flora and fauna. And again, a relatively short half-life in the field. It biodegrades in sunlight and stuff. So in this particular case, the decision was made to treat twice, so 2 applications to these spray blocks to make sure that things were effective. This was the first study or practical experience in Maine with this approach. So it was done twice to be sure it was effective. And so going forward to 2021, so again, we've identified some additional hotspots, and so these are in these 2 zoomed in areas in northern Maine there. So again, this is the same area where that original hotspot appeared, but you can see the 2021 L2 counts performed at this. This is the hotspot from 2020 right here. So that original Cross Lake Square Lake hotspot. So that's been totally knocked back, and 0 to 1 larvae average per site there. So that's great. So again, things are still kind of shifting around the landscape here. So we do have a couple points here that have been identified as hotspots, as well as out here on the Canadian border. So. And those have been treated as well. And then, next year's results that are kind of being looked at right now will kind of resolve that. So, but actually, no, I forgot that the results are already in. So here we go. We can look at these as well. And you can see those 2 zoomed in areas, pretty much quite low L2 numbers that are in so far. I don't think this is totally complete for the season yet, but this is what's available right now. So you can see nothing in that hotspot range. We do still have a couple of these yellow spots up here that are 2 to 299, but those are still below that threshold of 7 larvae per branch. And this seems to be the area that will continue to be a little problematic. There seems to be persisting populations here in this general area. This is an area where we've seen defoliation on the ground, defoliation during aerial survey. Again, these hot spots, and Madawaska also being there with that highest average pheromone trap capture for 2 years in a row. So this is, again, all these surveys kind of can point us to the right areas to really focus on. Obviously, we're focusing statewide, but this is an area of special concern up here. So that's what we're going to keep an eye on. And yeah, looking at this one that was on the Canadian border, again, a lot of these points seem to be knocked back and reduced. So, oops. And then, yeah, I guess I went through that pretty quick. But anyways, I do want to point out a few things. This was a lot of material to digest. So all of this is available online now. So the 2022 annual report, where most of these figures and graphs is also featured. That's right on our Spruce Budworm webpage. Amy will put that in the chat so folks can go right to it. You'll also see on the right-hand side of that web page that there are, all the annual reports going back to 2015. And if anybody needs anything predating that, we can probably find that for you. But that's certainly good local or good recent context for what's going on. I do want to, just take a moment to again thank all the cooperators. So I don't have logos for all our 20 plus on the ground cooperators for the pheromone trap monitoring network, but I know, again, certainly some of you are on the call, and thank you for your past help. And yeah, we're already spooling up for this upcoming season, so I thank you for your help in advance coming up. And yeah, University of Maine, both the CFRU Cooperative Forestry Research Unit has been hugely helpful in sharing some of these efforts. And yeah, now that the University of Maine Spruce Budworm Lab is there, it's absolutely fantastic to have this resource at our disposal and to provide really real-time, good results that are useful to land managers. And that is ultimately the goal of all of these programs, is to provide that information to folks so they can manage how they need to in a timely manner. So, all righty, with that, I'm happy to take any questions.
Hey, Mike, it's Regina. I have a quick question about the aerial defoliation surveys. How do you guys distinguish year to year, once you've picked up defoliation, that it's not the previous year's defoliation that you're seeing? Seems like a skill set.
Whoops, 1 second, Regina. I'm just trying to get my desktop reorganized. Okay, so yeah, basically for that example of what we did, so yeah, we started that season in 2021 there, knowing that we had X, Y, and Z pockets on the ground, and we actually visited them on the ground first to figure out, or some of them that figure out that it was spruce budworm, because again, this is nobody that's currently doing aerial survey with us has that search image yet. We haven't seen it since the 90s, and there's nobody still on board. So yeah, we kind of documented that spruce budworm is in those areas, and then flew them purposely to get that search image from the plane. And yeah, it's hard to say even whether we would pick all that stuff up, without some of those ground reports first. But basically, yeah, flying those same stands in 2022, just seeing no damage at all. Totally normal color profile for those things. So again, they focus on the new foliage at reasonable population levels and stuff, and they won't go on to the older stuff unless they're desperate. So yeah, 1 year of recovery is enough to kind of distinguish that damage, that it's not present 1 year from the next. So, but yeah, it's not simple. So it's our best interpretation of what we're seeing up there. And yeah, there's a lot of interesting work being done. I'll add on some of this remote sensing stuff, spectral imaging, to see if there's a better way to do this with reflectance and UV and things like that. So I think probably some hope for that in the future to make this stuff super reliable.
Awesome, thank you.
Hey, Mike, this is Jim O'Malley, and I'm just curious if there's any evidence, even if it's only anecdotal, are the population numbers of the natural predators increasing? Would that explain why the L2 numbers got knocked down?
Oh, that's a great question, Jim. I have no data to support that anecdotally or officially. Unfortunately, a lot of our monitoring efforts are really tied to monitoring the pest itself and not some of the beneficial stuff. I would hope that those populations are pretty healthy in a lot of the places where spruce budworm, is existing, and not subject to a lot of other, pesticide exposure like agricultural systems and stuff like that. So yeah, that's an interesting question. I mean, there's a lot of broad spectrum insect decline based on things like climate and habitat change. But I'd like to think that a lot of these areas in the North Maine woods are pretty stable as far as what the landscapes look like and stuff like that. So I hope there's not those declines and those populations are staying healthy at the moment. But yeah, great question, and yeah, it'd be fun to have a grad student or something look into that was monitored back in the day when these monitoring programs were really looking at every part of the puzzle. So yeah, there's probably some baseline data available from the old days that could be compared even for that. So
Great.
yeah,
well, thanks. Thanks. Keep up
Jim.
the good work.
Thank you. Let's see, did anything come into the chat itself? No.
No.
All right. Who's got another question? Anyone? Well, yeah, it's a lot of material, so I guess I'll make the offer again. Take the time, review those reports on your own time. I'm always available to talk to this stuff about anybody. I've done, I know some of the cooperators here, I've done individual, presentations for some of the big forestry companies on their individual results and stuff, that are cooperators in the network. I'm always happy to do that quick if there's interest in stuff like that. But I left a lot of time for questions. I thought we'd be packed.
Well, that's okay, Mike. I'll take the opportunity to let folks know that we are kind of moving away from that Forestry Friday format, having a specific time and place where these webinars from the Forest Service are presented. But that there will be continuing webinars from the 3 divisions of the Maine Forest Service. And those will be both listed in our newsletters, the foresters list, the loggers list, and the landowners lists, and also on our website, mainforestservice.gov. So you can stay tuned to those resources for upcoming webinars, and we really do appreciate your attention to this topic.
Well, I want to add that for anybody who wants to take the quiz for CEU credits, the quiz will be open until tomorrow night at midnight, which is Saturday night.
Great. Okay, thanks, Allison, and thanks, Amy, for those additions. And yeah, if there's no last minute questions, then again, I thank everybody for attending and your attention, and feel free to reach out, and I hope you all have a wonderful day. So long.